Right, well, good morning, gentlemen. My name's Paul Haddon. I'm part of the sales and marketing team for Sun Hydraulics. I want to talk about today as to our next generation of counterbalance valves. We're still specialists in control valves. We're into pumps, cylinders. We do pump cartridge valves in manifolds. We are getting involved in electronics. But we're committed to innovation and bringing new products into the marketplace. And this is two new products that deliver hopefully some benefits to different customers in different ways. Can I ask, this is sort of going at the clever end of counterbalance valves, so how many in the audience use counterbalance valves? Know what they are?
Yep.
Okay, good. And you use Sun counterbalance valves? Well, you're doing the right things. And have any of you explored the family of counterbalance valve that Sun does? Okay, right. So what I'm going to do to start with is just have a look at some of the characteristics of counterbalance valves and take us in the direction of what these smart valves are all about. We'll look at then the load adaptive, which is a product that's just been launched. So you say, well, where are you applying them? Well, I don't know, I'm not sold it yet. But it's a very new launch product. The second product, though, is the top end of our range, the load match. And we're seeing now customers using those for different reasons. Counterbalance valves. Fundamentally, they're there to stop a load running ahead of the pump or the control flow. Okay with that? Two typical circuits, really simple circuits. To the left, vertical cylinder with a load pushing it down, and our counterbalance valve off the full bore is there to hold the load, but also if we want to lower it, to give us steady, defined control. To the right, similar situation with the a winch, where again we want to make sure that we can control the lowering of the load on the winch with a counterbalance valve on the outlet of the hydraulic motor. Now, for a counterbalance valve to give us motion control, it will consume energy. Everybody's counterbalance valve to control motion will consume energy. It's not just a something. That simplified circuit, two things to note, P3, P1. P1 is the load-induced pressure, the load pressure. P3 is the pilot pressure. But in that hydraulic circuit, note, while it's the pilot pressure, if we are driving the cylinder down, it's the pressure that we've got to build up to lower the cylinder. So it's the energy that we're consuming to lower a load that would come down under gravity. So it's inefficient in its concept. What we find is that P3, the pilot pressure, and P1, the load pressure, act together to open the relief valve section, which is set to hold the load. Okay with that? If the load pressure is high, the pilot pressure is low. That sounds quite reasonable. However, if the load pressure is low, the pilot pressure is high. So what we find is, to lower a lower load consumes more energy. We can mitigate some of that if you have a high pilot ratio counterbalance valve. You can reduce the pilot pressure. But a high pilot ratio counterbalance valve compensates less for machine instability. Just a comment there. We'll have valves come back to us, and if you have problems with our valves, don't hesitate to send them back. They will be tested. However, we'll be told that the valve's not stable, and we'll put it on test, and it will be stable. The issue is it's machinery that's not stable. And what we find is that by choosing the right valve for the application, we can try and compensate for that instability, or we can amplify that instability by the incorrect selection of the counterbalance valve. So a high pilot ratio saves on pilot pressure, but it doesn't help us with machine stability. A low pilot ratio valve will give us better stability if needed. Not all machines need it, but it will if needed, but it will increase the pilot pressure. Add to that when you set that valve, you have to set it for the maximum load. And we recommend 1.3 times that. That takes up for the pressure differential between the cracking and the fully open of the valve, so that when we want it to, the valve snaps closed and we can get it as good as we can to leak free, and many sun valves are. But when we're opening that valve, we've got to open that maximum pressure regardless of the load on the cylinder. So all in all, with low loads, our valves aren't very efficient at all. So the challenge become, well, what could we do about that? And we termed it as pursuing of the perfect counterbalance valve. Our designers got together with a brief to think about how could you get the stability when you want it, but keep that pilot pressure as low as possible to minimise the energy being consumed. If we could do that, we could reduce energy costs. Okay, fuel's not quite as expensive as it was, but think about it, that's a blatant, obvious saving. We could reduce energy costs. In successful applications so far, that's turned into with skip loaders, increasing battery life. Skip loaders, residential areas don't want the diesel engine on, so the actual mechanism of the skip loading and unloading done from battery. So if we can limit the energy consumed, remember a skip loader is a very good one for being positive and negative loads as it moves, we can increase battery life. We could run actuators faster at lower loads. This is with horsepower control technology. So if we're sensing a lower pressure, the pump will go to a fuller flow, so we could increase the speed of an actuator. We could reduce heat generated. Yeah, if we put too much heat into our system, we've got to invest in money to cool it back down with air blast coolers and such like. Where we've got multi-pump systems, where we've got simultaneous functions, there is the opportunity to divert the energy saved from that lift-lower application to another function to improve machinery performance. So our first move here today, is perhaps the junior model, but it is a newly launched product, is what we call load adaptive. As the strapline says, and we have some of our competitors here today, but I'm still prepared to say that some counterbalance valves are probably the best performing counterbalance valves globally. So you're getting that market leading technology, but we're going to save some energy as well. I'm not a valve designer, I'm an applications engineer, so I'm not going to talk about the complexities of how that valve works. A gentleman asked me a question in the last presentation. We do have some of the history of it, but I'm focusing on, well, what is it, what does it do, what can we do with it, and some application tips, rather than this piston moves and such like. So we've got a CB style counterbalance. Our CB is our standard counterbalance valves. We're selling millions and millions of them. We sell, I would guess, 5,000 every working day of our range coming out of Sarasota. It's evolved, it isn't the valve it was when it started, but it is our standard CB style counterbalance valve. We're adding to it what we're terming a new pilot ratio driver. So what we got, tried and trusted performance from the CB range. It's still adjustable, so we can at least try and set it to give us our optimum performance. And 2 years ago we did a presentation here about that leaving valves set too high is actually the first move to consuming more energy than you need to. And then we've got this pilot driver, which is going to dynamically change the pilot ratio in the valve according to what it senses on its load pressure inlet. These are test stand results that we're going to look at. It's a simplified circuit, but if we control the flow and the pressure, the load pressure, to the inlet of a counterbalance valve. We can set it, and then by monitoring the pilot pressure, we can see what pilot pressure we need to open that valve. Starting with, if you take our standard counterbalance valves, pretty well most people's standard counterbalance valves, this is the sort of thing you would see. On the vertical axis, that's our load pressure. On the horizontal axis, the pilot pressure, P1, P3. He's referring to those two. The plots on there are vary with the pilot ratio. And what we see on the left-hand side is a high pilot ratio valve, which, as the load pressure falls, the rate of gain of increase of the pilot pressure is limited compared with the other curves. So we're seeing the 10-to-1 pilot ratio help us in an energy situation, but we know a 10-to-1 will not give us such good motion control. To the right is a low pilot ratio, I think it's 1.5-to-1. It's quite stiff, where we would use in applications where we're concerned about stability. But now we can see, as the load pressure falls, how far out our pilot pressure is growing. And that we know is our inefficiency. We also start to think, well, what's happening with a valve? When we're seeing either high or low load pressures, they can tend to be where you don't need stability. The start, where we're opening the valve. But in the middle of that stroke, we're looking for our optimum stability. Key thing, all of those show fixed pilot ratio, fixed slope. What we started to say is that when we've got low loads, we can have quite an inefficient energy-wise situation. But we've got to compensate that with the need for stability. If we do the same test, same circumstances with the load adaptive valve, we see something different. Same axis, vertical is the load pressure, horizontal is the pilot pressure. There's two flows there. Let's focus on the blue, the 60 litre a minute plot. And we can see three distinct regions. We can see the first, top left, we can see that high pilot ratio effect, whereas load pressure is falling, the increase in pilot pressure is limited. Middle section, more like a 3-to-1 or a lower pilot ratio valve, where as the load pressure falls, the pilot pressure is increasing somewhat more. But we know our low pilot ratio is giving us much better motion control against that overrunning load. If we go down to the end, where we're coming to the end of that stroke of the cylinder, we're seeing now a return to a steeper slope, more indicative of our 10-to-1 high pilot ratio energy efficiency, where we may not need that stability in the machinery. So we're looking at the fact that we've got low pilot ratios to improve stability, and we've got the features of the high pilot ratio when we don't need it to offer so much stability. If we look at the two together, we've got our standard valve, red, on the right hand side, and we've got the green, the load adaptive, on the left hand side. The difference between them two is the lower pilot ratio, and we know that flow in litres a minute times pressure in bar over 600 is the power. So if we're reducing the profile of the pilot pressure, we're reducing the power to lower this load. This is information that's been publicised in the States, where we took that actual test, that test bench, and started to quantify it a bit better. got a cylinder, 2-to-1 ratio, 280 bar setting on the valve. Remember, we have to get that valve open to start with. We're looking at the motion at the beginning, that's when we are opening that valve, but then when we're into the fuller stroke, looking at different flows. Let's pick my favourite one there, 60 litres a minute at the beginning. We're seeing the recording with our standard counterbalance valve, 35 bar, and we're seeing with a load adaptive valve, 20 bar. A 43% reduction in the pilot pressure required at that stage. And back to our formula, that is 43% saving in the energy being consumed at that stage. The average across load adaptive, from what we're seeing from our tests, and actually can be concurred with our load match, which we're going to come on to, is that in the right circumstances, you can look to save 30% on energy. What's the right circumstances? Well, with load adaptive, they tend to be best for lower pressure, maximum 280 bar. Remembering, our valves are 350 bar rated. So if we want the best out of our energy savings, high cycling, lower pressure range. Application tips. The load adaptive is no better as a motion control valve than our standard range. So you've still got to think about, when selecting counterbalance valves, you've got to think about that primary pilot ratio. Do you believe you need a high pilot ratio, a low pilot ratio? We've got a limited selection available at the moment, 3-to-1 the most standard, but you still do have to think about the selection of the valve for the application. You also have to think about that we know for best motion control, if you've got a 60 litre a minute counterbalance valve, you want to use it as near as possible to 60 litres a minute. Might give you some reverse flow issues, and I know customers will put another check valve around it just to get a lower pressure drop on the return flow, but you do want to try and match the valve to the flow. Certain things Sun can do to help that. We have 4-port valves and atmospherically vented valves. Does anyone in the audience know what they are?
Yeah.
Yeah, okay with some, right? What essentially they are is that if you've got, we talked about P1, P3, P2 is the outlet of the counterbalance valve. If you see pressure on there, unfortunately that acts against, or with the setting, against the pilot and the load. So we need vented valves to avoid that issue. You can have 4-ported, or you can have atmospherically vented. And as of yet, that's not available in load adaptive. They're working on that idea. If it's a new application, it doesn't matter too much, but if you want to replace and upgrade or to try an application, see how you're doing, load adaptive is bigger. It's the same cavity, so it's interchangeable, but it is longer. So just to watch that as an application tip. What we've launched so far is the size 1, series 1 valve, 60 litres a minute in its standard format, 3-to-1 pilot ratio. But we do have variants that about matching to flow, what we call our semi-restrictive and our restrictive valve. That's nose technology, where for a size 1 valve, we're producing a valve that still works well in terms of motion control on much lower flows than that rated 60 litres a minute. So we've got a semi-restrictive for 40 litres a minute. We've got a restrictive for 20 litres a minute. We also have ultra-restrictive, and I've used those successfully. It flows up to 8 litres a minute with over-centre situations. In fact, there's a rig here with them on, where we go over-centre. There's a much tighter valve for the worst sort of stability scenarios in CB form, the 1.5-to-1 pilot ratio that's due soon. The family of Sun counterbalance valves. And what we're looking at here with load adaptive is simply the first move from our standard CB valves on the left-hand side and saying, let's have some energy savings. That's what the load adaptive is about. Right, any questions on that? Any quick questions on that?
At the present time, they're not proportionally large. They've obviously got a 3-position in there by the graph.
Yes, yes.
To 3 positions.
Yeah, it is feeding off the pilot,
yeah.
but it is to say it's not directly proportional.
Yeah.
It's going through 3 phases.
Yeah.
Is the ratio always the same, 3-to-1, 10-to-1?
As far as I know, yes. I think that's within the design. They're looking for the 10 and the 3. It's not by nature it seems to be producing that effect. But again, I'm not a valve designer, so I do hesitate.
What's the main reason for choosing 10 at the beginning? Because quite often when you have that first initial metering, that's when you can have instability. And
You
at that
can.
point, you'd go for a higher
You
ratio.
can, yes. I think that's a balance that you'll see with your applications.
So that's
But it also is the case that while we're opening the valve from its setting to crack it open, that's a very energy efficient, inefficient stage.
right.
But I'll take your point on some applications, you get this point, you get this lunge. But you'll tend to get that anyway.
Yeah.
And the counterbalance valve, it was about how does it compensate for it. A poor counterbalance valve or some valve that's not been applied correctly will tend to keep that going. A high pilot ratio will tend to amplify it. So you're right, it's a point to watch when you are sizing your counterbalance valves for the particular applications.
Do you actually have, I assume you do have to consider the full bore to annulus area when
That comes into
able
those
to
calculations.
select a ratio.
But yes, that's featuring in it, but fundamentally the lower pilot ratios give you a stiffer system, higher pressure in both sides of the cylinder, and better stability on the machinery.
Right.
Higher pilot, did I say that correctly, but higher pilot ratio is it's not such a stiff
So
system.
you should go as high as possible. And
For
save
energy
power and
efficiency,
go for that time.
yes, in a
Yeah.
sense, go for as high as possible as long as you've got stability,
Yeah.
because you've got energy efficiency.
Yeah.
But the main pilot ratio that we supply, main product is 3:1. It's a balance of, it's not too energy inefficient. The whole concept of it is energy efficient, but you are giving yourself a reasonable amount of stability on the machinery.
Well, with the load adapter, is it totally automatic? It's tamper proof. There's no margin for fine tuning it between a range. Once you've selected that,
Yeah.
that's it, is it?
You're selecting the valve, but you are setting the valve. And so if we talk about that first phase where we're opening the valve,
Yeah.
if we've set the valve too high for the application, we're extending that period. You can argue perhaps I can set it high and load adaptive will balance it out for me. You might find
So it's
just
important.
investigate that in the application.
You've got to choose it based on.
You've still got to think getting your right counterbalance valve for the box. We're taking standard technology and putting energy saving onto it. So you've still got to think about selecting that valve correctly.
Are those different flow rates in the same cavity that you do, or are they different?
Yes, that's essentially you've got the same cavities, the T11, with the standard semi-restrictive and restrictive valves and ultra-restrictive.
Okay.
All the same cavity, it's within the valve that we're changing to cope with lower flows.
Right,
Okay? Right. The Big Daddy, load match valve. As the strapline says, we've got that market leading technology. We're going to save some energy, we're going to save some time, and we're going to save some inventory. It's a valve that brings a number of features, number of benefits that different customers are picking up on. And as I say, this has been out in the market 2 or 3 years now. Quickly run a little video. On the load match valves.
Sun Hydraulics load match valves are counterbalance cartridges that allow the setting of the valve to dynamically adjust in response to load pressure while still providing a fixed thermal release setting. They seat like a poppet, resulting in low leakage, and modulate like a spool valve, providing benefits of both types. Load match counterbalance valves self-set at approximately 1.3 times actual load. These valves operate at lower pilot pressures than typical counterbalances with the same setting, reducing energy and extending the runtime of battery-powered machinery. Load match valves work well in environments where high setting is required with much lower varying load pressures. These valves are available with a setting range of 280 bar up to 420 bar. Available in 3 frame sizes, Series 1 load match valves are 60 liters per minute cartridges and include non-vented and vented versions. Series 2 load match valves have a capacity of 120 liters per minute and are available in 3 versions, non-vented, atmospherically referenced, and vented. Series 3 load match valves have a capacity of 240 liters per minute and, like Series 2 load match valves, 3 versions are available. Load match valves allow you to reduce inventory complexity by reducing the number of cartridges needed in your system. One load match cartridge can take the place of several counterbalance valves with different settings. Load match cartridges are physically interchangeable with Sun's counterbalance, load holding, and pilot to open checks, making them easy and convenient to retrofit into existing installations. To learn more about Sun's growing family of load match counterbalance valves, visit our website at www.sunhydraulics.com.
Right, let's have a look at that a bit closer. There's one thing, just looking at that video, that I could ask you to do, is regarding our website. Sun is now putting a lot of time into more and more information going on to our website to help people when they're applying our valves. The old catalogues used to be well regarded because they had technical tips. So you went into counterbalance valve PO check, there'd be a section on the range, how to use them, give some tips as applications engineers. But because we haven't lost those, but they're now as technical tips on the website. Sun is putting a lot more time into putting additional information in videos, in webinars to help people understand our product range, which is really quite a massive product range. And you can sign up on the website for highlights. You essentially get an email, probably once a month, that will certainly talk about any new launches of products, and it may give you some additional information about existing products. It may talk about a successful application. It's good engineering stuff. And you can then go to the website if you wish and read more. In fact, much of the load adaptive, much more than what I've done there, is available on the website. For me, records would suggest the UK is the poorest take-up of highlights in the world. So please, if you could, might save my job on stage, but have a go. It's there. You don't have to carry on taking them if you don't enjoy them enough, but they're really quite good. The Sun is putting a lot more effort into talking about its products and what to do with them. And that's one way of hooking into it. Again, I'm not going to talk about the valve, but I'm going to talk about what it is and how we use it and such like. I'm going to start with the family this time. Far left, we talked about our standard counterbalance valve, our CB range, and at the right hand is our load match. First advantage of load match, we talked about that load adaptive is not available as of yet with invented forms, either 3-port atmospheric or 4-port vented, but the load match is. So it can be used on regen systems, it can be used on meter out proportional systems to give you motion control. It will deliver that same 30% energy saving that we've seen with our introduction of the load adaptive valve. Does anybody know what our M-valve technology is? Or our M-valve counterbalance valves are? Okay. We're getting rather geeky now. An M-valve could be said to be a seated flow control valve. It first originates from controlling winches, where we take a separate pilot from a joystick or a proportional reducing valve, and we can open the valve and control the speed of the winch coming down. That's done by market-leading technology. As far as I know, no one else. In fact, it's very much like a proportional valve in itself, of the internal mechanism. It's very different to the CB, which is essentially a poppet valve, but these are like seated spool valves. And they deliver exceptional fine control, so they're very good when you have major instability issues. And they're also very good across a range of flows. We talked about with the others, match it to the flow, the maximum you could. But these, they'll work well in fast approach, slow at the end of the stroke. We don't have to be so worried about matching the valve to the flow. We're going to add to that that we no longer adjust them. It's self-adjusting. A bit more on that. M-valve technology with this unique self-adjusting feature. If if I can say. It's still got that same floating nose technology that makes us leaders in this area, the industry. It adjusts itself. It dynamically adjusts itself based on the pressure that it's sensing on its inlet. The pilot ratio, this energy efficient drive now, is we want to keep pilots down, and we'll see pilots go even lower now, and we'll see that they're not independent on the load. We talked about how that pilot changed with the low pressure. With these valves, it's not. That M-valve technology is about gain. A low gain valve, as it moves, it opens up the flow more slowly. So we've got that ultimate gain control for our M-valve technology. There is a setting, it's just by choice. I believe there's 3 settings. This is the maximum 420 bar. What you're thinking about with that is 3 things: thermal expansion, 5 buckling load on a cylinder perhaps, also the setting that you're looking for based on what your maximum load pressure is, albeit you're not actually going to set the valve. So these are suitable for load holding up to 350 bar, back to that multiplied by 1.3. To the 420 is its maximum setting. There's 3 fixed settings to choose from. There's some internal features that help us understand how this valve can work reliably. We've got a valve that is going to respond to the load pressure. So if the load pressure is going to increase, the valve needs to respond quickly so that we don't lose the load. Top left, internal, we've got our supply pressure coming in, P1, and as we run through to the pilot section, we're going to move that top hat to the left, and the oil flow will go through the centre, through the orifice, and around the outside. So we're going to bring our pressure sense into the pilot section as quickly as we can. But conversely, bottom left, talked about the valves are stable, but if we decompress as the load goes down too quickly, we could well have instability in the valve. That's no different to a relief valve fluttering. It's the same issue that we need some sort of damping to stop it fluttering. So in this instance now, the top hat moves to the right hand side and stops the flow around the outside. So we've got fast response to make sure we don't lose this load that's increasing, and a slightly damp decompression so that we keep stability in the valve itself. A couple of other features. On the pilot flow, entrapment annulus and reciprocating control oil. Technical comments there, but they're quite interesting. If we look, difficult now going from one screen to the next, but on the purple we've got the 2 annular grooves where our pilot pressure is coming into the piston, and we want to get that through as quickly as we can. But if we then go over an increased tolerance on the circumference of that piston, we're essentially entrapping contaminant. Now, one thing I would say is I've had customers talk to me saying we don't like cartridge valve technology because you use too many small orifices within the valves. Now, I'm from an industrial background, and I know there's plenty of small orifices in industrial valves. And another thing I would say, as hydraulics progresses and some of the things you learn at the NFPC, I think we are better understanding contamination control in our hydraulic systems. So I'm prepared to say a sun counterbalance valve is no less sensitive, more sensitive, than other equipment within the circuit. But nevertheless, a couple of things there to improve the situation. The second one on the right is that, yes, we're talking about contaminant in the fluid, but what about contaminant in the air? And we've talked about these vented valves. Vented valves breathe. As the chamber is pressurised, it expels air. But conversely, it then draws air in. So if we've got dust, moisture in the air, we're drawing it into the valve. So we've upgraded the seal mechanisms to do 2 things: to seal better the incoming air, But also remember, we are using O-rings to separate the wet area of the valve to the dry area. O-rings are wet in themselves, so there is a constant transmission of fluid from the wet side to the dry side. And you'll see this, I've seen some quite acute situations, not with sun valves, and we've seen people sometimes say there's a problem with the valve, is that if you're in a dusty environment, the valve starts to wet in the area of the atmospheric hole connection, and if it's in dust it goes a lovely black colour. And that is the atmospheric valve, which eventually will see some moisture on the outside. So what we've done with the valve there is to try and improve that. Minor points, but part of this sort of top brand product that we have. But probably more interesting, looking at the performance curves. These curves are looking at pilot pressure, running different curves for the load pressure, 70 bar, 140, 210, bottom right corner on each graph, and these are against flow. But you can still see for a 280 bar setting, at a low load, the red curve, you see how that's jumping up high. The others with the higher load appears more efficient. Our pilot pressures aren't rising as fast. When we go to M-valve technology, that's the middle one, we actually start to see some benefits anyway in that technology. That they're not rising as fast as the CB. But when we take that then to our load match design, we see two things. We see that regardless of the load, they look very similar. So it's suggesting, or it's telling us, that they are not, pilot pressure is independent of load pressure, which is what we want, especially as we can see, we've kept it as low as possible as well. So there is the route to our energy saving on those valves. Benefits. Quite candidly, we've done a couple of presentations on load match, and we used to say, when a customer said, well, how much is it? We said, well, you're missing the point. So you should be thinking about what it's going to do for you and how much it costs. But I'll probably soften that up because we've got some prices, but we'll start with the idea of what's the benefits of this valve, see what the investment is in it. So we've got, with this load match, simpler valve selection. Because we've got M-valve technology in it, we know we've got a valve that will work well across a variety of flows. As long as we've got an awful rough idea what our maximum is, we don't have to worry too much about what might be happening in the machine operation. We know now that we've got our energy saving regardless of the load pressures, and we don't have to worry about the setting of the valve to maximise or minimise wasted energy. We've got ultimate motion control. That can enable us to do things to avoid instability in machines that you may not have been able to with other valves. We've reduced commissioning skill, and reduced time. We've got customers who used to have hydraulic service engineers and diesel engine service engineers, and now diesel engine service engineers can change the valve, which is changing that valve over. There's nothing for them to adjust and to worry about. And remember, these valves hold loads, so when you're on site, you have to think about that you do it correctly. There is a hazard to adjusting, replacing counterbalance valves. But because there is no adjustment on this, we're reducing the potential for hazards on site. It's the ultimate plug-and-play counterbalance valve. There's a lot of technology into choosing the right valve, installing it, commissioning it, servicing it. But this valve is taking away a lot of that, but also delivering 30% energy saving as well. And that point that is shown on the video, I haven't got an example for this, but I think it will come, because we've all experienced the idea of rationalising our supplier base, the cost associated with dealing with more suppliers. It's the same comment then of the cost of dealing with more and more valves. And with standard valves, non-sun and sun, you're looking at different settings. You're looking at different pilot ratios. Then within our family there's some other tweaks about restrictive, non-restrictive. what we're doing is we've got a valve that could replace all of those. So we're reducing inventory. The surface engineer's got to dash out. It's less likely if you're using load match that he finds he's took the wrong valve on site. What do we have? Well, we've progressed more with this product range. The three sizes we call our size 1, size 2 and size 3, 60, 120, 240 litres a minute. There are a couple of pilot ratio options to pick, so to think if you feel it really is quite an aggressive instability in the machine, go for a low pilot ratio, but they should be good anyway. And the size 4 valve is on the way. It's also available in the standard 3-port vented, non-vented valve, but you can have the atmospheric vented and you can have the full port. Just a reminder on those two, regen, proportional meter out systems. The vented we think of, so the atmospherically vented we think of as a fix. Because a lot of people will use non-vented valves on a proportional system and find they have got instability. The valve bouncing around, closes, opens, closes, opens. So because the cavity is the same, you can take that one out and put an atmospherically vented valve in, and it will cure that problem. But you do have the aspect that it's connected to the atmosphere. So the proper valve for the job is the 4-port valve. The downside of the 4-port valve is we would promote that you put your load holding valves and your motion control valves as near as possible to the actuator, but you've now got to run another pipe back to your tank. Prices. Standard CB range. I know you're all shooting to the right, so I'm going to go through them. CB range, £42 sterling list, UK at the moment. If you go to your load adaptive, so let's take that technology and save some energy, £69. Vented valves, 67. These are size 1 valves, because the size 2 and size 3 are far more expensive. If you move to the M valve technology, which is a jump from the left to the M, if you've got severe stability issues on a machine, lung boom machinery in particular, it's a very hazardous one to get stable operation. We go to £75. The load match, that top product that we have, £154. So just before we finish, I just would like to remind you what you invested if you're prepared to pay the £154. Load adaptive, good motion control, energy saving. Load match, simplest valve selection. I'm time poor. I think all application engineers are time poor these days. It makes it easier to pick that valve at the application stage. If you've got improved motion control, there's a fair chance you could get your machinery to work faster and still be stable. Got machinery advantage. Site, that time, talk about service people here, the cost of being on site, the hazards of being on site, the regulations that you've got to meet to do it. And we're bringing that down to a minimum and taking out as many hazards as we can. And it will deliver you that 30% energy saving, which we looked at on the load adaptive, you could use in different ways on your machinery. And one valve replaces several others. If you find an opportunity for that, let me know. So I think that will have some benefit to customers as time goes by. Okay, thank you very much. That's the load match valve.